Hello everyone. Today I am going to discuss the last problem of Leetcode Weekly contest 452, which is maximize count of distinct primes after split. So what is the problem? We are given an integer array nums of length n, and we are also given 2D integer array queries. So we are given q queries, and in each query we have to update a particular index of nums to a particular value. And after that, what we have to do after each operation, we have to print one thing, that we have to split the array into two halves. One is prefix and another one is suffix. Now we have to find the sum of distinct primes in both the parts. Okay, so let's take the first example. Let me copy this thing in my editor. So let's say this is the given query. Okay, this is the given nums and this is the query. Okay, so this is right. Now at the first operation, what we have to do, initially we have like 2 1 3 1 2, right? Initially we have 2 1 3 1 2. Now we are changing the first index, zero based indexing, we are changing first index to 2. So after updating, the index will be like this, the array will be like this, 2 2 3 1 2. So what could be the possible splits? I think we can mm, let me check. We have to split from 1 less than equals to k less than n. That means that we have to split them in two non-empty halves. So what we can do, we can split here. So the number of primes here is 1 and the number of primes here is 2. 2 and 3 are prime. Okay, so this could be one possibility. Other possibility is splitting here and here, then also this will be 1 and this will be 2. Another possibility will be splitting here, then it will be like 2 and 1 here, like that. There are multiple possibilities, but in both the cases the answer is 1 plus 2, which is 3. Okay, in all the cases the answer is 3. Now what is the second operation? So second operation is it is 2 1 3, current state is 2 2 3 1 2. Now in the second operation, what are we doing? We are changing the third index 0 1 2, third index to 3. Okay, we are changing the third index to 3. Now what could be the possible split? One possible split will be like to do this is the most optimal split, because we are getting two primes from here and two primes from here. One other possible split will be by splitting it here. Okay, splitting it here, but here we will get one prime and here we will get two primes. Then the answer for the above split will be 3 and the answer for the lower split will be 4. So our desired answer will be 4. Okay, so answer is 3 comma 4. We have to find the maximum number of count of primes. Okay, now how we can solve this problem? Okay, so let's try to solve this problem. If there is no updates, okay, if there is no update, then how we can solve this problem? So let's say we have like initial array was 2 1 3 1 2. Okay, so what we can do, okay, we are splitting the array into two halves, right? Not equal. We are splitting the array into two halves. One is prefix and another one is suffix. So let's say we are at some index I. Okay, now we have taken prefix from 0 to I. Okay, prefix from 0 to I, let's call it prefix of let's call it prefix of I. And then we have taken the suffix from I plus 1 to n. We have taken suffix of I plus 1 to n, let's call it suffix of I plus 1. So what prefix I denotes? Prefix I denotes the number of distinct primes in the prefix from 0 to I. And what suffix I plus 1 denotes? Suffix I plus 1 denotes number of distinct primes from I plus 1 to n. So what this is nothing but, the answer is nothing but, if we ignore the queries, the answer for a normal array is nothing but, for I equals to 0 to n minus 1, for I equals to 0 to n minus 1, prefix of I plus suffix of I plus 1, that is our answer. Okay, now there are some requirements for this problem. One requirement is how we can identify primes. So let me write it in text format. How we can identify primes. So for identifying a prime, the brute force solution, for let's say we are given a prime, then what is the time complexity we can identify a prime? So we can check all its divisors in order of square root of n, and we'll check that if a number divides it, then it is not a prime. So order of square root of n. But here you can see that AI ranges from the constants. Okay, from the constants. Okay, from the constants you can see that AI ranges from 1 to 10 to the power 5, 1 to 10 to the power 5. So we can use pre-computation. Okay, we can use pre-computation. So a common approach for pre-computing primes, I hope you all know it, it is called sieve. Okay, sieve of Eratosthenes, I don't know the spelling, so let's call it sieve. So time complexity of sieve is order of n log n. Okay, Order of n log n is the time complexity of sieve. So we can identify each prime from 1 to n using this sieve of Eratosthenes. Okay, so we can pre-compute the prime values from here. So we can check the sieve algorithm for identifying primes. This is the first requirement. Now the first requirement is done. Now uh, here comes how we can solve the problem. So brute force solution, let's discuss the brute force solution plus. First, the brute force solution will be to let's say we are changing this value to, let's say we are changing this value to 2. So changing this value to 2 means that it is updating all the prefixes and all the suffix values. So we can iterate over I equals to 0 to n minus 1 again, and then again recompute prefix I and suffix I value in order of n. So brute force solution is order of n for each query. So brute force solution is order of n into q. This is the our brute force solution. Okay, so brute force solution is order of n into q. How we are solving it? So we are updating a value for a particular query, and then we are again computing the prefix and suffix array. By in that case, we can solve the problem in order of n into q. Now here you can see that n is around 10 to the power 5 and q is again around 10 to the power 5. So this approach will not help us. Order of n into q approach will not help us. Now we have to think something better. Okay. Now what uh, what we can do? Okay. Let me take some time. Okay, so I'm back. So what we can do, right? So here you can see that we have something like prefix I and suffix I plus 1, and we are doing a max operation here. So after seeing this constant, I thought about how what are the data structures we can use for finding maximum in a range. Okay, maximum in a range. So that is segment tree. Okay, we can use segment tree here. So this is my thought process, that I thought what is the complexity, time complexity could be order of n or in log n, and what is the range max data structure we can use. So we can use segment tree. So then I thought that should I use two segment trees, okay, for a segment tree for prefix and segment tree for suffix, but that is not helping us because we want to maximize prefix I and suffix I plus 1. It is not the case that we are maximizing prefix I and suffix I plus 1 separately. So we are just actually maximizing the sum. Okay, so instead of storing prefix I and suffix I plus 1 separately in the segment tree, let's call it seg, for a node seg I we'll just store prefix I and suffix I plus 1. Okay, for a node I we'll just store prefix I plus prefix I plus suffix I plus 1. Now we'll check how it is getting updated when each of the update operation is getting performed. Okay, this is a handling case, like different cases are there and we have to handle the cases separately. Okay, so let me take some examples. Okay, so here let's say I have something like uh, 575. Okay, 5 let's say let's take something more, 5725 232. Okay, 5725232. Now let's say I am changing the I am changing the 5 to 7. Okay, I am changing this 5 to 7. Now just think about two operations. Okay, first operation is we are deleting 5. Okay, we are deleting 5. So two operations are there. One is delete 5 and another one operation is add 7. Okay, delete 5 and add 7. If I want to think about the two operations in a single atomic operation, it will be hard. So I have divided the single operation in two parts. One is delete 5. So now if I delete 5, okay, if I delete 5, let's say there is a 5 at the end. So let's think about suffix now. Okay, at first let's think about suffix now, then we'll think about prefix. So let's say there is a 5 there. Okay, let's say there is a 5 there. So this 5 does not change the uh, number of distinct primes in the suffix because there is already 5. So this is not incrementing the value of the number of distinct primes. Okay, so this is not incrementing the value of the number of distinct primes. So when we are deleting 5, it is not affecting any of the suffixes. I hope you got it. So if there is a 5 or there is a number which is at the right side of this, I am only talking about suffix, right? So let me write, we are talking about suffix, only talking about suffix now. Okay, so let's say there is a value which is at the right side of the current element and we are deleting the current element, so it will not affect any of the suffixes. So we are safe. But let's say 5 is not there, right? So let's say 5 is not there, then what will happen? Okay, let's say 5 is not there, then what we can say that whenever we are deleting 5, it will just increment all the values. It will just increment all the values in the range 5 to 7. It will increment all the suffixes from here to here. Sorry, my bad. So it will decrement all the suffixes from these three parts. So this will be -1, this will be -1, and this will be -1. I hope you get it. So what we are doing is we are taking the last occurrence when we are deleting 5. So there are two cases. One is if there is a 5 right side of the current 5, then we are not doing anything. Now if there is no 5 before after this, then we are checking what is the 5 before this. So this is the 5 before this. So let's call that let's call it j. Okay, so let's call it j. So what we are doing, we are just changing from j plus 1 to I. We are decrementing by -1 the suffix value. For j plus 1 to I, for j plus 1 to I, we are decrementing the suffix value by -1. So delete operation is done. Now we are changing it to 7. Okay, we are changing it to 7. Now the first operation is done. Now we are changing the adding 7. Okay, adding 7. Is there a 7? Is there a 7 after this? Is there a 7 after this? No, there is no 7 after this. If there is a 7 at the right side of this, we will not do any operation like we have done for 5, deleting 5. But there is no 7 after this. So what we have to do, we have to, when we are adding 7, the unique primes will increase by 1 here and here. So let's say j is the index of the last previous 7. So we are just updating from j plus 1 to I. We are updating it by +1. This is same for deleting also. We are decrementing it by -1, and for updating it also we are incrementing by +1. So there are four cases here. Deletion and adding. For deletion there are two cases. One case, if there is a 5 right side of this, we will not do anything. If they otherwise we will increment j plus 1 to I by -1, decrement j plus 1 to I by -1. And in similar case for adding 7. Now I am not going to explain the prefix case. You can think about the prefix similarly like suffix. So you can reverse this part, like prefix and suffix are ideally same. It is just doing the same operation in reverse order. So I am not going to explain the prefix, it will just longer the video. You can think about the prefix once. Now I will explain my code, how I am handling this. Okay, let's go into the code. So before this, so what we are doing, we are handling prefix I and suffix I separately, and we are storing prefix I plus suffix I plus 1 in the segment tree. I will explain that part in the code again. Okay, so this part is for my segment tree, segmax class. So segmax class will take lazy propagation, help of lazy propagation. Okay, uh, I will provide some link in the description box. You can check that out for segment tree max. So this is our segment tree code, and this is our sieve code. Okay, sieve is prime will give us if a current number is prime or not in order of one time. So this is our sieve class. Okay, so these two classes are done. Okay, now this is the main function. Okay, now uh, we are also having ms. So ms of namsai. Okay, ms of a val will contain all the indices in the sorted order. So ms of val will contain all the indexes in sorting order. So let's say ms of 2 here will be ms of 2 here will be a set. Okay, ms of 2 here will be set. So it will be 0, index 0 will be there, and 1 2 3 4, 0 and 4 will be there. So ms of 2 will contain a set of 0 4 like that. Okay, I hope you get it. Now here we are doing the prefix I calculation and the suffix I calculation. Okay, here we are calculating prefix I and suffix I plus 1. Initially the value prefix 0 value is 0, prefix -1 value is 0, let's say. Now if it is a prime and it is not visited, then we are incrementing the value of the c. Okay, c is our prefix I, c is nothing but our prefix I. So we are using one based indexing here. So I prefix I will contribute to I plus 1. Okay, prefix of I will contribute to I plus 1, and suffix I plus 1, suffix I plus 1 will contribute to I. So prefix I will contribute to I plus 1, and suffix I plus 1 will contribute to I hope you get it. So that's why for I we are doing I plus 1 comma I plus 1 comma c. So prefix I plus 1 will be updated by c, and similarly for suffix I plus 1 we are updating it to I. Okay, I hope you are getting it. So here we have calculated prefix I and suffix I, and here we are doing an update operation. So in the update operation, you can see the segment tree. We are doing segment node plus equals to value. So it is not setting the value at a particular index to C. It is incrementing the value at a particular index by C. I hope you get it. Now this part is done. We have already done the pre-computation for prefix I and suffix I plus 1. Now we come into the query part. Okay, now there are 4 cases I have already explained. Okay, so if it is, if the current number num psi is not prime, then we are not doing anything. Now if it is a prime, okay, if it is a prime, so we are checking that if I equals to previous of num psi dot 10, that means I have told now this I, if this I where I have explained. So if 5 is the last 5, okay, 5 is the last 5, then we are only considering that case. If 5 is the last 5, then last value is if the size is 1, if the size is 1, then the previous, we just need the previous 5, okay, previous 5. Let's say there is no previous 5, then the previous value is 0, okay. uh, so if ms of nums of size is 1, that means there is only one 5, then the previous will be 0. So you can call it previous or last, anything. Otherwise it will be the last to last 5, okay, last 5 is this, and last to last 5 is this, and we are updating last comma I by -1. So we are updating last to I by -1. Here you consider that for suffix we are using I for I plus 1 we are using I hope you are getting it. So we are doing is dot update last comma I comma -1. Okay, I hope you are getting it, because we are taking plus 1 here. So this part is for the suffix. Okay, this part is for the suffix. Let me write. So this part is for the suffix, and this part is for the prefix. Okay, so I am not going to explain the prefix part. You can check it out yourself. Okay, uh, this part is for prefix. You can check it out yourself. Similarly, if the val is prime, if val is not prime, we are ignoring it. Okay, and if ms val size is 0, that means val is not present, or the previous value, okay, when that means that this val is less than this, okay, there is something at the right side of this, okay, then we are doing the operation. Okay, if that there is nothing at the right side of this, we are doing the operation. So if the ms val size is 0, the last value is 0, otherwise the last value is previous of ms val dot n plus 1. So this is similar. Similarly, this is for suffix and this is for prefix. I hope you are getting it. And we have to do one thing. So whenever we are done with a num psi, we have to erase the index from that num psi. Okay, and similarly we have to insert the index for ms val. Okay, and we have to set num psi equals to val, and we are doing answer dot pushback s dot query 0 comma n plus 1. So we have to find the maximum value from 0 to n plus 1. Okay, so what is the overall time complexity? The overall time complexity for C, we are doing like max. Okay, max is here, let's call it max. So order of max log max for sieve. Okay, max log max. Here max is 10 to the power 5. Plus for query we are doing order of log n operation. So overall time complexity is order of n plus q log n. Okay, this is the overall time complexity. I will provide the link of the code in the description box. You can check that out. I may not have explained each and every part of the code because it will longer the video and this is repetitive. You can check my code, and if you have any doubt in any part of the code and explanation, you can always ask in the comment section. I will try to reply each and every comment. If you find this video helpful, please like the video, subscribe to the channel, and also share among your peers. Thank you.